Okay, so today we're going to do lesson 5. I'm going to try and get through this unit before the last week of classes, which is next week. So I guess I'll try to get through this all by next Friday. I did assign assignment 4 yesterday. I went through all the examples, so hopefully you've been working through that. You may not have finished it. That's all right. It's quite a long assignment, so just keep working away at your own pace. What we're going to do now is we're going to work through the examples for surface area. So now we're entering 3-dimensional shapes. So far we've talked about 2-dimensional shapes, which would be flat, something that has no depth or height to it. That's what we've been looking at. And now we talk about 3-dimensional shapes, which is the world we live in. We're a 3-dimensional world. So, for example, we have height and width and depth to our bodies, like a piece of furniture that you look at. Anything living is 3-dimensional. So once again, just like we've I've talked about this before, a 3-dimensional shape has a length and a width, but it's not just flat like the desktop. It actually has a depth to it. So sometimes depth is also called height, depending on what the object is that we're discussing. There are two main measurements that we're going to talk about, the surface area and the volume. We're going to talk about surface area today. Basically, you can think of this as surface area is the amount of material it would require to make or manufacture a shape. And volume is the amount of stuff that we can put inside the shape. So if I use a Kleenex box as an example, the surface area of a Kleenex box would be the amount of cardboard that it takes to make the box, and the volume would refer to the amount of Kleenex I can stuff into the box. So again, now we're going to talk about the surface area of common shapes. We've got our 4 common shapes that we're talking about, but in a 3-dimensional manner, I suppose. Let's just talk about surface area a bit more. And once again, I'm just going to talk about surface area today. I'm going to leave volume till next week. So surface area is exactly the same as area, but it's the measurement of the area of the surface of an object, a 3D object. For example, let's examine the cylinder below. So the cylinder is sort of the shape that we would refer to in an everyday language as like a can. This would be like a can of juice, or the tube of a toilet paper or paper roll, or if the cylinder was a little shorter, it would be like a tuna fish can. There's lots of things that are cylindrical or tube-shaped in our world. But if we want to define the surface area, now see that word area that's embedded in that? It's part of the word surface area. So we've got area. So even though we're talking about a 3-dimensional object, we're still talking about units squared, because basically what the surface area is, it's the sum of all of the areas of the outside shape. And I think surface area requires the most thinking, because if we want to find the surface area, we would need to see how many square units would be required to cover the outside surface of the cylinder. Okay. So if I just think of this soup can, I'm trying to think think of it almost as if there was a mesh that was laid on top of this cylinder. So see the mesh wrapped around the outside and laid on the top of the can and the bottom of the can. And what I do is I would count whatever I was measuring in, if this was centimeters or inches, I would count all the squares if I could. And then that would tell me how many squares of material or fabric or tin or aluminum, whatever I'm making the can of, that I would need to manufacture the can. So imagine the cylinder is a soup can. You could take a marker and cover it with squares, like centimeters squared. So if each one of these was 1 centimeter by 1 centimeter, each little square would represent 1 square centimeter. Now, if I could add up all of these centimeters, I would know how many square centimeters of material I would need to manufacture the can. Okay, Now, the problem is it's really hard because three-dimensional shapes have a shape to them, right? Like a can would have a rounded wall. It might be easier to lay something and measure like with a ruler or something straight the top and the bottom of the can, but it would be very hard to do the sides, which is why we rely on formulas. Okay, so what we say is the surface of any three-dimensional object is just a collection of two-dimensional shapes put together in such a way that they create a 3D shape. Okay, so to find the surface area, you need to find the area of all of the two-dimensional shapes and add them together. Since that would be very difficult to do by hand, and especially for very large objects, for example, what if the cylinder represented a grain silo in the middle of a farmer's field? It would be far too difficult to measure that by hand. So we're going to take a look at the formula for the surface area of a cylinder. So any cylinder, if we go back to this, our little soup can over here on the previous page, if you think about the soup can, if you ever really look at a soup or a tuna can, you can see that there's seams around here. There's seams around the bottom where the wall and the lid of the can, or the wall and the bottom of the can meet. They weld those together. There's also a seam coming down. If you look at any can, there's sort of a seam coming down the wall where this piece of metal was seamed to enclose the shape. Now, if I took off all those seams, like if I cut all those seams apart, what I would be left with for the shape of a cylinder is, if I unrolled the tube, I'd be left with a rectangle, and two circles. Okay, so that's how we have to think of surface area. If I took whatever shape I'm given and I dismantled it and took it back to its constituent parts, I would have a rectangle and two circles. So all I have to do is find the area of a rectangle, find the area of my rectangle, which we'll talk about this in a sec, and then find the area of the two circles. Let's do the circles first. The area of each circle is pi r squared, So I have two of them, right? If I put them together, I'll have two pi r squareds. So that is the area of the two circular, the top and the bottom of the can, I guess, or the lids of the can, if you want to think of it that way. And this is the wall of the can. It's a rectangle. Now, the rectangle, this measurement would be, normally I refer to a rectangle as length and width, but in this case, because the cylinder is standing upright, it's a soup can, this would be called, that we usually refer to it as the height. Okay. So h is height. And remember, r is radius. And if you think about it, this was the curved wall that went right around, if I just draw my little can here again, okay, this piece of if this is the height of the can, this piece wraps around in a circular manner. Remember, the perimeter of a circle is 2 pi r, okay? This is the perimeter, or circumference, that's the correct word, circumference of the circular base or top. Okay, so 2 pi r. So the area of this rectangle would be 2 pi r times h. So that's how we get this formula. So in entirety, in total, the surface area of a cylinder can be found by finding the area of the rectangle, right? This is the area of the rectangle, That's the first piece. And this second piece is the area of two circles. That's it. Now, this is important. If you were trying to find the surface area of an open-ended circular, something like a soup can with no top, you would just omit that part of the formula. So you would just need one rectangle plus one circle. So that's important when we get to the applications, the application questions, that you remember that if they tell you you're dealing with a cylinder with no bottom or a cylinder with no lid, you don't need both circles, you just need one circle. So let's take a look at some of the other surface area formulas. So these are, of course, you would always be given the formulas on any test or assignment. You never have to memorize. Even if we weren't in lockdown mode, like quarantine mode, you wouldn't have to memorize these. So these are the surface area formulas you're responsible for. We've given the technical name and then the layperson's name, right? What we usually call it in real life. So we're going to be exposing you to and making sure that you know how to calculate the surface area of a rectangular solid, which is a box. And I'll go through these in a moment. A sphere, which is a ball. A cone, which kind of looks like a three-dimensional triangle, right? Now we've seen cones before, of course, an ice cream cone, traffic cone. They're used a lot in manufacturing too, right? If you look at the inside of a cement truck, it's a cone shape that churns the cement around before it dumps it out on the ground. This is our cylinder. Notice this is a much shorter cylinder. It's flat. It's more representative like a tuna can. Now these two might not be familiar to you. They're not as common in everyday life. A square-based pyramid. Now, square base, notice the base itself is a square. We'll talk about that in a moment. And a triangular prism. Kind of looks like a tent or the top of a house, of some houses. So let's go back to these formulas. A rectangular solid, you can see that it's made up of a top and a bottom. And if you look at the top of this rectangle, if I just look at this for a sec, this is the width, right? The width and the length. So the top and the bottom, if I wanted to find either the areas of either one of these, it's just length times width. The front and the back are the same, basically the same rectangle. So it's h times L, height times length. And then either end, these ends, it is width times height, right? Width times height. If I want to find the surface area of this whole box, like how many pieces of cardboard I would need to make the box, I need two L times W's, like the top and the bottom, the front and the back, and both sides. It's hard to explain this one other than the surface area of a sphere or a ball is just 4 times pi times r squared. It's kind of difficult to explain that one. You can Google more about that though if you're really interested. Now here, this cone shape, I have two constituent parts. I have the circle and I have the actual, like the wall, the curved shaped wall. So this is the wall, right? Another, like the wall or the side. And this is your circular bottom, right? Notice again, it's just the formula for a circle, pi r squared. So I need to add the side and the circle together to get the cone. We've already talked about the cylinder. So here, the square-based pyramid is composed of one square base, right? This is the bottom. It's one square. Now the sides, okay, it's 2 times b times s. So I have 4, this constitutes 4 triangles. It's just a shortened form for 4 triangles, the area of 4 triangles. So the bottom and the 4 sides. I know it looks odd here, and again, you could either ask me to go into more detail, but they've taken the areas of 4 triangles and condensed them together, and it simplifies to 2 times b times s. Now, once again, triangular prism, we've got Again, this is shortened form. These are the ends are the two rectangles, or pardon me, two triangles, these end walls. It's a little hard to see because these actually have been actually simplified. And when we simplify the formulas, a lot of canceling happens out. So that's why the 2 disappears. And then the sides, the two rectangles, we've got two rectangles here. So the triangular prism, this takes care of all 3, like the 2 walls here and then the bottom. These are what's referred to as the sides. Now, because it's just accumulation or a summation of area, surface area is still units squared, because each area, what we're doing is we're finding the areas of each wall of the shape and adding them together, so we stay as units squared. Then we talk about volume, which I'm not going to talk about today. I'm going to leave volume. Again, we have to find the volume of the shapes. We use the same shapes though, so it's not a new set of shapes. And I am just going to, there are a few examples here. Actually, not many, right? So let's just find the surface area of these shapes, and then maybe we'll get to volume as well today. We'll take a look. So find the surface area and volume of each of the following shapes. Okay, so surface area of a cylinder equals, okay, I'm going to record my formula, 2 pi RH plus 2 pi r squared. Okay, so let's see. This is the height, right? This is the height. This is not the radius, that's the diameter. So the radius has to be half of that, which would be 6.5. So the surface area of this cylinder is going to be equal to 2 times pi times 6.5 times 20 plus 2 times pi times 6.5 squared. Okay, so the surface area equals 2 pi times. So I typed it all into my calculator so I wouldn't have to round it. I just want to round at the end. So I get 1082.28 centimeters squared. Okay, so not too difficult as long as you recognize the parts. So again, if I was manufacturing this, perhaps a juice can out of some kind of metal, this is how much metal I would need to buy. All right, let's take a look at this. This would be the surface area of a triangular prism. And the formula is, I have to flip that because I don't have this one memorized. So it's going to be B times H plus L, A plus B plus C. And if you look at the formula, it actually tells you what all the parts are, the constituent parts, like what the symbols mean. So that might be something you want to refer to the chart as well. So this 12 is my H. H is 12. This is C. This is B. This is L. And we've got, this is also, A also equals 13. Okay. If this side is 13, then this side is 13 as well. Okay, so what's the surface area of this one? B times H plus L is 24, bracket A plus B plus C. All right, you can do all this in your calculator, but I think I might do a little bit of simplifying first. I think I would add these 3 up anyway, so that should be 36. Okay, so finally I can do this. and I get 103,680, and that double quotation marks are inches squared. So that's it. Unfortunately, they just have one example, which is not a lot, and then they have a very simple assignment. So maybe, I think that the tough part comes in lesson 6. So maybe I'll quickly go over volume and then let you do the assignment tonight. As I said, the volume of these shapes is the surface area calculated how much material you'd need to make the shape, and the volume is how much stuff I can put inside the shape. Because obviously you're making this shape or these shapes to do something with them. So let's take a look at the volume formulas. They're actually easier than the surface area. Volume is used to measure three-dimensional objects, but it measures the amount of space inside a three-dimensional object. Okay, so that's the inside space. Surface area is the outside covering. Volume is the inside space. Let's look at this box, which is technically known as a rectangular solid. To measure the volume, you fit as many cubes of a certain size inside the box, like our little 1 centimeter cubes we were just kind of looking at, but they're three-dimensional. For example, we'll use a cube with sides of 1 centimeter. These are cubic centimeters. Anytime, now we're measuring in 3 dimensions, so we're going to be using cubic centimeters. So our exponent will have a little 3. This is the only measurement that will be in cubic units. Area and surface area are always units squared. Volume will be units to the power 3, which is also referred to as units cubed. So here I have a box with dimensions, a height of 4, a length of 9, and a width of 4 as well. If you took the time to actually, like if you had some little dice-shaped things and you could fit them inside the box all nice, neatly and evenly, you'd find there's 144 of these little cubes that could fit in. We don't generally have time to do that, though, in our day-to-day lives or in math class, so we use a formula. The formula for volume of a box is length times width times height, and that also gets you 144. And that's a much quicker way of getting the measurement for volume than to do an individual count. So once again, we're going to revisit our shapes. I don't have to explain the shapes to you, but here are your measurements for volume. You can see it's much easier. They involve just one step because we're just measuring the space inside, and that's just all found in one part, right? It's just the inside. So the inside of the box, the inside of the ball. What would go inside the ball? Well, air, right? The inside of the cone, the inside of the can, the inside of the pyramid, and the inside of the prism. You can see why surface area was so much harder because we actually had to break the shape up into its constituent parts. But when we're talking about volume, we're talking about a measurement of when all the individual parts are all assembled into one unit, one cohesive unit, and we're just talking about the inside of that cohesive unit. So here are your volume formulas: length times width times height. Let's take a look at volume of a sphere. So that's 4/3, 4 divided by 3 times pi r squared. R, of course, is radius. The volume equals 1/3 times pi times r squared times height. We don't need the s in this formula. We needed the s for surface area. Volume of a can or a cylinder is pi times r squared times height. This is 1 divided by 3 times the base squared times height. And this is 1/2 times b times h times l. So we don't need a and c in this. So I can even just scribble out the c, scribble out the a and the c if you want. Okay. Let's do the volume. Let's do the volumes of the cylinder and volume of the. Okay. So volume of the cylinder. I'm looking. Volume formula is pi r squared h. Volume of the cylinder. So our volume becomes pi. We already knew what r was. Times 20. So that's easy enough to punch in. They're actually easier to punch in because there's less parts usually. 6.5 squared times 20, and I get 2654.65 centimeters. Be very careful. Cubed. Volume is always cubed. Anything with area, surface area, or just area is squared. Volume is cubed. And then finally, the triangular prism. Volume of triangular prism. 1/2 times B times H times L. So 1 divided by 2 times 10 times 12 times 24. So I get 1440 inches cubed. Notice I don't use the double hash, just like I avoided using them in the area unit because it doesn't look right. So I always write the word inches out. So that's a lot of practice for you. I don't know if you, maybe what I'd like you to do is work on the assignment, and I'll write the answers down for assignment 5 before class is over. And then lesson 6 is going to be the big one, right? It's going to take us a bit of time because it's applications, and then it starts with irregular stuff, and then we move to applications. So it gets a little trickier later on. You really have to think. So let's take some time, work on assignment 5. I'll leave the examples up for you, I suppose. Let's move them over a bit. And take a look at example 5, do a little bit of work, and then I'll come back maybe in 15, 20 minutes, and I'll do example 5. It's really straightforward. It's just applying the formula. Sorry, we'll regroup in a minute or so. Okay, I am going to finish. I'll do the questions from assignment 5 just before we leave for today, and then we'll have caught that up, and then we'll talk a little in more depth about lesson 6. So surface area and volume of each of the shapes. Well, we can see that the surface area of the box or the rectangular solid, I'm just going to quickly look. So remember we have 2 LWs and 2, how did they write it? The order doesn't really matter. LH and 2 WH. This would be the L, length, width, height. Okay, so the surface area of this shape is 2 times L times 8 plus 2 times L times H plus 2 times 8 times 8. And if I put that all into the calculator, I get 1088 meters squared. And volume is really easy, right? Length times width times height. So volume equals 30 times 8 times 8. 1920 meters cubed. Okay, so that's my surface area. That's my volume. Now, the surface area of a sphere, I'm just going to quickly look at I'm just going to grab another measurement book. So surface area of a sphere is 4 pi r squared. So this surface area is going to be 4 pi. This is the radius, so I don't have to do anything. 37 squared. Okay, so what do we have here? 4 times pi times 37 squared. I'm going to have to do some rounding. 17203.36 millimeters squared. So that's the surface area. I'm literally just going to my formulas, right? I don't have these memorized in my brain. I'm just going to my formulas and copying down the formula. Volume of a sphere is 4/3 pi r cubed. Notice there's a cube there for volume. So it's going to be 4 divided by 3 times pi times 37 to the power 3. Now remember, you should know where your exponent button is on your calculator, right? 4 divide 3 times pi times 37. There's my exponent button. So I get 212,174.79 millimeters cubed. Right, and now we have our cone surface area. So there's no thinking involved here really, right? You're just plucking the formula out of the formula chart. So my surface area equals, and recognizing which part is which, right? That's a tough one. This is my diameter, right? So that's not in my formula at all, right? And this part, this is my L. That's my H, which you can see is not part of the surface area formula, but it is going to be part of the volume, right? So that's H. This is diameter, so radius equals 3. Just going to put this is my L. Okay, so my surface area is pi times 3 times 5 plus pi times 3 squared. Okay, so I type this all into my calculator at the same time. Pi times 3 times 5 plus pi times 3 squared. And we get 75.40 if I round to 2 decimals. And that little tick represents feet, so it's feet squared. Now notice once again, I didn't need the h for the surface area, but I do need it for volume. So the volume of a cone is 1/3 pi r squared h. So the volume of this cone is going to be 1 divided by 3 times pi times 3 squared times 5. And that's going to give me 1 divided by 3 times pi times 3 squared times 5, 47.12 feet cubed. And then finally, sort of the odd-shaped thing, this surface area of a square-based pyramid is b squared plus 2 times b times s. This, of course, is b. Notice they have, if it's a square-based pyramid, these measurements have to be the same. And the only other measurement is, oh, this is a little hard to read, isn't it? Something looks a little off there, doesn't it? Just gotta double check this. I think for the volume, I think it's kind of, what am I going to do here? I think this is the height, the 28, and I'm going to say that this is the S equals 30. Okay, so surface area equals 20 squared plus 2 times 20 times 30. So 20 squared plus 2 times 20 times 30. And I get 1,600 centimeters squared. And then volume equals, the volume of the square base is 1/3 b squared h. So that's why we needed this h here. 1 divided by 3 times 20 squared times 28. I guess it's 28.28. 1 divided by 3 times 20 squared times 28.28. And that gives us a volume of 3770.67 centimeters cubed. So that was my volume of the square base. So when I say there wasn't a lot of thinking involved, I just mean you didn't really, you just have to recognize the shape. These weren't in any sort of context. These were just basic shapes. So formula. So today, as long as you could just get a sense of what all the parts represent and put them in the right place in the formula, awesome. For the next class, I think tomorrow I'm going to give you a work period to catch up on other stuff because I know that people have not been writing tests, and I really want you to start, I guess, contacting me and get some tests written. And then we'll finish up with the irregular shapes next week. Okay, so that's it for today.